So to start, I'd like to thank you all for coming, and I'd like to thank the organizers for this opportunity. Mobilization of modern design. Architects and artists pursue camouflage during World War II. During World War II, architects and artists mobilized their knowledge of color, light, shadow, material, and texture to assist the military with camouflage. New technologies, such as aerial photography, infrared photography, and the airplane itself, changed the task of camouflage considerably. Not only was it necessary to conceal military installations from a viewer on the ground, during World War II, it was increasingly necessary to prevent bombing of civilian areas far from the front. Over 20 schools, including the Pratt Institute and the Chicago School of Design, offered wartime courses in camouflage to train designers in the theories and techniques of civilian defense, concealing factories and confusing aerial bombers. The Museum of Modern Art prepared 2 versions of an exhibition called Camouflage for Civilian Defense, which toured many of these schools between 1942 and 1944. The MoMA show displayed models and other materials assembled at the Camouflage Laboratory at the Pratt Institute. Through courses and exhibitions, architects and artists contributed their visual expertise to the war effort, educating camoufleurs and explaining the strategies of camouflage to the public. Camouflage presented an opportunity for architects and artists to enhance and mobilize their knowledge of basic visual principles through collaboration with scientific and technological experts. Through guest lectures at the Chicago School of Design, coordination of the MoMA show with camouflage engineers at Fort Belvoir, Virginia, and the creation of a laboratory of camouflage at Pratt, architects and artists used artifice to flout technologies of vision in support of the war effort. The task of camouflage required architects and artists to reverse their normal task. Instead of using light, color, and material to realize a 3-dimensional form, the camoufleur used his skills to hide forms. In order to do so, artists and architects needed an understanding of basic elements of visual perception and a particular understanding of the visual experience of the enemy. Moreover, the illusion would have to fool both the human eye and the technological aids to vision available to the enemy, as graphically expressed in this panel from the MoMA show. The panel read, quote, "Camouflage must deceive both the eye and the camera," end quote. In contrast with World War I, which was mainly a war over position, World War II was a war of movement, where the vision of the enemy was assisted by new technologies of vision. In addition to advances in aerial photography, infrared, and stereoscopic photography, the camoufleur needed to understand and anticipate the enemy's view of the landscape, assisted by the airplane itself. Increasingly, it was the view from above that threatened industrial and urban areas, and it was this view that the camoufleur most needed to understand. Camouflage courses emphasized the importance of camoufleurs spending time in an airplane, observing the landscape from above. Military and civilian experts believe that giving the students the chance to experience the aerial view themselves was a necessary part of learning to create reproductions of natural or contextual features. Students were taught to look at the landscape from the air, to see buildings and natural features as navigational aids, quote, target arrows and camouflage problems, as in these images from an Office of Civilian Defense publication called Precautionary Camouflage. Similarly, the instructional manual produced by Conrad Wittmann at Pratt explained the differences in vision from 12,000 feet, where reflections of the dominant visual cue, and 10,000 feet, where patterns of urbanization begin to be useful. The manual encouraged students to pay attention to features which produce lines, and to realize that round forms, such as oil tanks, are conspicuous to a viewer in the air. In addition to the view from the airplane, the students of camouflage were taught to understand the technological assistance offered by infrared and aerial photography, which were used for reconnaissance. Aerial photography could enhance an image and make detecting features far easier. Additionally, a series of images taken over time could be compared to reveal significant new construction. Construction sites were particularly difficult to conceal, and during wartime, the enemy could confidently assume that new construction was almost certainly an airfield or a factory. A further challenge was presented by the new techniques of infrared photography, which also enhanced the vision of the bombardier. Infrared photography could produce an image under hazy conditions, if not heavy fog, allowing photography in a greater range of weather conditions. Infrared photography was also successful at distinguishing between natural and artificial foliage. Where the leaves on natural trees appeared gray on infrared images, the artificial foliage would show up black. At the Chicago School of Design, Laszlo Moholy-Nagy and Georgi Kepes's students learned of the development of specific paints designed to flout infrared photography from one Mr. Merle Sweet, the president of the Research Association of the Northern Pigment Company. The students also learned about mobile photography units developed by the military in a lecture by Lieutenant Kenneth Carson. Lieutenant Carson spoke about techniques for night photography and infrared photography, and while he would not state the precise power of those cameras for security reasons, the students were impressed with the technological ability to make the invisible visible. However useful photography was for enemy reconnaissance, the vision that truly mattered was the so-called process of vision, by which the bombardier selected and targeted a site on the ground. This sequence was presented to students in a variety of sketches, two-dimensional diagrams, and even an installation at the Camouflage show held at the Advertising Club of New York in 1942. In its most detailed form, such diagrams explain the sequence of visual events that occurred as the bomber approached the target. The process began with the bombardier sighting distant landmarks at points A and B, and alerting the pilot at point C, then opening the bomb sight and bay doors when the plane was still 60 seconds from the target, or point D. The possibility for precision bombing decreases rapidly if the bombardier is unable to see the target clearly by the time the plane is 35 seconds away, or at point E. At the 35-second line, the bomb sight is engaged for the release of the bomb at F. Studying the process of vision was intended to provide two lessons for the camoufleur. The first lesson acknowledged that while complete concealment of an airfield or oil tank was unlikely, the ability to disorient the bomber was still extremely valuable in preventing precision bombing. Even if the camouflage job only succeeded in confusing the bomber enough that the plane needed to make a second pass, it greatly increased the chance that the bomber would be stopped by anti-aircraft fire from the ground or pursuing aircraft in the air. The second lesson from the studies of the bomber's process of vision was the importance of designing camouflage to have an effect at a distance of 4 to 8 miles away, to create confusion in targeting and require that second pass. Equipped with an understanding of the technological enhancements to the enemy's vision, the student of camouflage studied the basics of visual perception, broken down into a series of simple, easy-to-apprehend lessons about visual perception. The courses at the Chicago School of Design were organized this way, as were the manuals of camouflage produced by the Pratt Institute and those produced by the U.S. military. Indeed, the majority of the 23 panels in the traveling show produced by the Museum of Modern Art were concerned with conveying basic principles such as pattern, shadow, and texture. Patterns were used to break up the shape of an object, as shown in this panel from MoMA's camouflage show. The column on the left shows disruptive patterns, cautioning students and members of the public that it is very important to extend the treatment past the boundaries of the object, because a pattern contained within the shape of an object can attract attention rather than distract. The second column illustrated the use of pattern to imply depth, as might be used to conceal a large, flat roof. The third and fourth columns presented more specific treatments of objects, breaking up recognizable shapes to confuse the enemy bomber. In his lectures to students in his camouflage courses, Kepes explained how overlapping shapes could imply depth on a flat surface, following a well-known lesson of modern painting. The study of shadows was another important aspect of camouflage, as shadows help the viewer from above to discern the shape of the object. The principle was shown compellingly in a set of before and after photographs in a manual written by Robert P. Breckinridge, a major in the U.S. Army Corps of Engineers. The first photograph shows a group of ordinary objects photographed from above, and the caption asks the viewer to guess what the objects are. The second photograph shows the same scene, but with shadows cast from an additional light source, with the result that the ambiguous objects are now easily perceived as a compass, razor blade, scissors, and eyeglasses. Indeed, the draftsman's technique of rendering shadows on a plan to indicate the z-axis prepared architects to understand the utility of shadows in perceiving three-dimensional objects. Similarly, architects' studies of the angle of the sun over the course of the day and throughout the year were applied to the task of concealing the shadows cast by buildings. Color was also studied as an element of camouflage, using the standard camouflage color palette developed by the military to mimic various natural environments. Students were told that some colors appear to recede and some to advance, a principle that could be used to enhance the impression of depth, as in classic optical illusions. In an expert lecture delivered by Colonel A.D. Tuttle, the medical director of the United Airlines, students at the Chicago School of Design were told that the color green stands out in the low oxygen environment aloft. The impact of texture and material on the perception of color were also studied, and students were presented with information about the use of materials to garnish the nets, placed over planes, tanks, trucks, and the sides of buildings. These materials ranged from burlap to feathers and included steel wool, which had the advantage of being inflammable. To avoid the problem of rusting or paint wearing off steel wool, various types of fiberglass were developed. Camoufleurs were encouraged to learn about color and pattern from animal examples, as in this image of a bird from the pioneering work of painter Abbott H. Thayer. First published in 1909, Thayer's book, Concealing Coloration in the Animal Kingdom, was a frequent reference for military and civilian manuals on camouflage. At the Chicago School of Design, students learned about the principle of counter-shading in fish from Juliet Kepish. From such principles, artists painted patterns on the roofs of large buildings and expanses of paving, as in this camouflage of an intersection which served as a landmark for a waterworks. Landscape architects used natural and artificial plantings to conceal objects, producing specifications for the gathering of natural material on the front, and for the construction of varying types of artificial trees. At times, fast-growing vines were attached to sections of mass-produced wooden snow fence, laid over the monitors of a factory roof to hide the characteristic shape. Architects produced light structures, nets, or canvas-draped objects called structural camouflage to blend an object into its context. Moving from so-called passive camouflage to offensive camouflage, architects continued the practice of razzle-dazzle painting on ships, which was used during World War I. They also constructed decoys, such as this decoy plane, out of canvas. While traditional artists were involved in camouflage, institutions of modern art and design leveraged their study of visual principles and their study of modern science to argue that they were uniquely suited to the task. At Chicago, Moholy-Nagy argued that his school's emphasis on studying visual principles made the students of the so-called New Bauhaus in America particularly good at camouflage. He was also able to argue that his students benefited from his ongoing belief in the importance of integrating science and technology into the introductory courses at the school. In addition to the experts in military photography and camouflage materials, whose lectures have been alluded to already, students of the Chicago School of Design heard lectures on perception from experts such as Dr. J.C. Copeland of Riggs Optical Company, who presented the functions of the retina and fovea and proceeded through the optics of lenses. As recorded in student notes, Copeland described the phenomena of parallax and explained that because of the relatively small separation between the two human eyes, the ground plane appears flat to a pilot after 640 meters. The studies of perception at the School of Design benefited from Jorgi Kepish's ongoing interest in the work of German Gestalt psychologists, as part of his belief in the importance of the, quote, social application of scientific knowledge, end quote. In 1944, Kepish described his indebtedness to the work of Wertheimer, Kafka, and Kohler for the diagrams in the New Vision that illustrated the fundamentals of visual perception. The link between Bauhaus ideals and camouflage studies were also apparent in the MoMA show, as described by a review of the exhibition by Emily Gnauer. Despite or because of the, quote, distinctly scientific, unarty handling of the show, end quote, Gnauer wrote that the show revealed the legacy of the Bauhaus through its belief that an artist must be both a practical technician and a dreamer. As at Chicago, the MoMA show introduced visitors to the most basic elements of perceptual psychology. After presenting the utility of camouflage to flout precision bombing, but before detailing the role of light, texture, or material in the experience of vision, the exhibition at MoMA presented a panel that described how, quote, vision depends on reflected light. The panel introduced the viewer to shading, texture, and reflection through a series of objects connected to an eye and a brain. The caption emphasized the major lesson of perception at the time, namely that the brain was an active part of understanding the light reaching the eye. The caption read, quote, recognizing the image is the work of the brain. The practice of trying out solutions through the use of small, simple models was compared with an earlier MoMA show on the Bauhaus itself. The models in the camouflage show were produced at the Pratt Institute as part of their exploration of design solutions for industrial objects, such as horizontal tanks, spherical tanks, chimneys, and in this case, grain elevators. Such projects pulled together all elements of the architect's visual expertise, shadow, texture, and material, as well as their understanding of the enemy bombardier's view from above. At a more immediate level, camouflage was not only about mobilizing design to assist in the war effort. The wartime courses at the Chicago School of Design were instrumental in keeping the school alive during the war, justifying its existence in hard times through the argument that it was contributing to civilian defense. Once the U.S. entered the war, the School of Design was threatened with closure. Faculty and students were called to serve in the military, and materials for the workshops were scarce. It was only through the quick production of a plan for wartime conversion that Moholy-Nagy saved the school. Through unknown means, Moholy obtained a half-hour audience with President Roosevelt, as well as an appointment to the mayor of Chicago's Civil Defense Commission. In this capacity, he was involved with a project to camouflage Chicago's waterfront in the case of invading aircraft. Additionally, Mr. George Kepish attended a course in camouflage at the Army Engineer School in Fort Belvoir, Virginia, allowing the school to grant a certificate in camouflage to graduates of its courses. The student body was somewhat limited by the wartime conversion, however. Students in the camouflage courses were required to be citizens of the United States, and some of the student work could not be shown in public. Other elements of the wartime conversion at the School of Design included courses on occupational therapy, designs for wood springs in response to metal shortages, and advertisements for Walter Pepke's American Container Company, touting their wartime uses as packages for rations, paper targets, and cardboard tubes for missiles. Even during the war, camouflage was not seen as a field of study which would disappear with the conclusion of the war. Official publications emphasized the continuing problem of concealment and civilian defense, even as early as 1942. The precautionary camouflage manual published by the Office of Civilian Defense included a diagram called, quote, our shrinking world. A sequence of 4 globes measured the distance from Europe to North America in terms of the transportation technology available for traversing the distance. In 1812, the voyage by ship took weeks. In 1914, steamships reduced that time and distance to days. In 1943, the distance was crossable by aircraft in hours, and the diagram questioned whether it might not be further reduced to a matter of minutes by 1950. Additionally, the precautionary camouflage manual explained the need for dispersal of buildings through a comparison of the vulnerability of buildings to that of bowling pins. Direct lessons for the design of buildings and the planning of regions were also presented in the Pratt Institute manual, as in this illustration of a design for, quote, natural inconspicuousness, elsewhere referred to as one of the, quote, new types of functionalism, end quote. In the modern camouflage manual written by Major Breckinridge of the Army Corps of Engineers in 1942, the Major wrote that he did not think that there would be another war right away. Nevertheless, he believed that the effects of camouflage would be retained long after the, quote, last bit of transplanted sod on the factory roof has withered and died. Breckinridge predicted that the lasting effect would be one of decentralization, not concealment, admitting that the trend to decentralization was not new. Instead, he described decentralization as in line with the beliefs of unspecified planners who had concluded that dispersal and the informal arrangement of buildings produce more happiness. Similarly, he applauded the changes in design that modern architecture had begun before the war, approving of their unadorned, flat roofs as easier to conceal than the monitors on old factory buildings. He also approved of the anonymous, unadorned buildings which do not announce their role in industrial production, and whose lighting and cooling technologies remove the danger of light shining through windows at night. Maintaining his denial of direct preparation for another war immediately following this one, still he emphasized that dispersal makes it far harder to kill a comparable number of citizens. He concluded that these plans are being undertaken in the event that it is ever again required. Perhaps he was right that in the future, the needs of camoufleurs and planners would be aligned. Aside from the problem of transportation, however, he feared that the increase in highways and airfields required to navigate a dispersed area would be far too easily identified and used as landmarks by the bomber. Whatever the lasting impact of camouflage on the dispersed settlement of the landscape, the mobilization of modern design clearly allowed architects and artists to continue work through the war and make the case for the utility of their skills. The study of camouflage provided modern designers with an area of expertise, namely the study of new technologies of vision and the creation of forms to flout those visions in service of civilian defense. Thank you.